Hello class, welcome to Math 62, section 2.1, solve equations using the subtraction and addition properties of equality. Under this section, we have four objectives: verify a solution of an equation, solve equations using the subtraction and addition properties, solve them requiring simplification, and translate and solve applications. We're going to look at them one by one. When it comes to verify a solution, we are looking at finding or determining if the solution that is given to us is indeed true for the equation. In other words, we need to see if it makes the equation a true statement when substituted. So let's try this using an example here. Determine whether x equals 3 over 2 is a solution of 4x minus 2 equals 2x plus 1. So let's take the equation. I'm going to write that equation here down. 4x minus 2 equals 2x plus 1. This is an equation. You have the equal sign, and you have two sides of the equal sign, the algebraic expressions. We need to see if this given number for x is a variable. X is usually the missing variable that we find. Here they've given us the answer and asking us, well, see if this is really the solution or not. And we just saw that it is determined if, when substituted, it produces a true statement. So I'm going to substitute for x wherever it occurs. And I strongly recommend that you use the shell method, which is just drawing shells in the place of a substitution. In this case, where I say shell, I simply mean parentheses. This way, the number that you're substituting, be it positive or negative number, fraction, or anything like that, you will keep the substitution intact without incorrectly merging or losing a negative sign and so on. So let's plug in 3 over 2 wherever x occurs. Now we do not know if this is going to be a true statement, so I put a question mark above the equal sign. Okay. Now remember PEMDAS, let me write that by the side here. PEMDAS. PEMDAS stands for parentheses, exponents, multiplication, division, addition, subtraction. This is the order of operations, and so we always follow PEMDAS when we deal with equations or expressions. So here we have, on the left side, we have to consider the parentheses first, and there's nothing going on in the parentheses, but you do have to continue on with the PEMDAS iteration. So if P, there is nothing to do within the parentheses, then look for E, there are no exponents. So move to M. M is multiplication. Actually, M and D, multiplication, division, you will do whichever comes first, left to right. So we have multiplication here. So go ahead and see if you can cross-cancel them. 2 times 1, 2, 2 times 2, 4. Likewise, on the right-hand side, we do the multiplication part first, where we end up doing cross-cancellation. Collect the terms that are remaining. So 2 times 3 is 6, minus 2. Still continue with a question mark. We have 1 and the 3 there, so multiply them. You have to multiply because there is parentheses there. That's the operation that it indicates. Multiply them, and now go ahead and simplify this. 6 minus 2 is 4, equals 3 plus 1, 4. Is this a true statement? And yes, indeed. 4 can only equal 4, so this is a true statement. This implies, this symbol here means implies. So this implies x equals 3 over 2 is a solution of the given equation. We always like to box the answers so that we know we've come to the end of the problem. Okay? So let's try maybe another problem for practice. Determine if y equals 7/5 is a solution of 5y plus 3 equals 10y minus 4. Once again, let's write out the equation. And we need to substitute for y. So let us draw shells in the place of y. There are two places where y occurs, so two places where you will insert the given value. It's given to be 7/5. Let's plug that in both places. And put a question mark above the equal sign. Wherever possible, simplify it. Here we are able to cross cancel it. 5 times 1 is 5. On the right hand side, you have a 10, so you get out a 2 from it. So simplify this by multiplying out what's remaining. So that's going to be a 7 plus 3 equals question mark. 2 times 7 is 14 minus 4. Go further, 7 plus 3 is 10 equals 14 minus 4 is 10. It is a true statement because 10 can only equal 10. Come back and conclude your answer. Say x is, I'm sorry, see I said x, we have a y actually. So we now have y equals 7/5 is a solution. Okay, so now we have looked at the first objective, determine. I would like for us to move on to the second objective, which is solve equations using subtraction addition properties. So let me take this down here. Sorry, you're hearing too many clicks now. Okay. Well, addition and subtraction properties usually tell us that if you added on one side, you should add the same quantity on the other side. For instance, if A equals B, if I added a quantity, say plus C on one side, then I have to add that same plus C on the other side to balance the equation. Think of, balancing panes. So you really have to balance them out by placing the same weight on both sides. Likewise, if A equals B, and this time you want to subtract a quantity C on one side, remember that you have to do the same thing on the other side as well. This is the property. So we're going to look at equations where we will apply these properties to find the missing variable. So the first question says, solve y plus 37 equals -13. Okay. Now this is asking us to solve. Solve means to find the solution. We need to find y. We are not given y. We need to find y. Okay. So to do that, you could do it intuitively by trying to see what number plus 37 will give me a -13. You must understand that it should be a very small negative number to do the trick. Again, you could do it by guessing, but in math, we have better ways of doing this. We don't have to guess. We simply have to use systematic ways of solving, and that will help us get the exact answer without guessing. So in this case, we want to remember to get y by itself. So I say isolate the variable y, which means get y by itself. Any one side of the equation. Now y is already on your left side, so we want to keep the y on the left side by itself, which means the plus 37 is in the way. The opposite of 37 plus 37 is minus 37, because that's the only thing that will cancel it off, right? Plus 37 minus 37 is a 0, so they cancel off each other. And as per the property, whatever you do on one side, you do the same thing on the other side. So I subtract 37 on the right as well. This helps us to get rid of the 37s on the left, leaving us with a y by itself equals. Combine these two. When you have two negative numbers to add, you will add the two numbers and take the common sign. So adding them gives us 40, and their common sign is negative. I'm sorry, 50, and the common sign is negative. So let's do the check. That's very important. We got the answer, but we need to know if the answer was right. Like in this case, I almost said negative 40. If that was the case, when I do the check, that will tell me that I was wrong, and I'll go back to fix my answer. So you have inbuilt check right here. So we always check by plugging it in the original equation. So original equation. We use the original equation because it's not tampered, and obviously because that is the question. So we have y plus 37 equals negative 13. And in the place of y, I have to plug in the answer I just got. Remember, when we check, we always put a question mark because we're still trying to determine if it is true or not. I plug in negative 50. In this case, when we are combining a negative number and a positive number, we have to subtract the two numbers and take the sign of the larger number. 50 minus 37 is 13. The sign of the larger number is 50, and the sign in front of it is minus. So negative 13 equals negative 13. Is this a true statement? Yes, indeed. It is a true statement. So we come back and conclude. We say this implies y equals negative 50. And that's the answer. We go ahead and we box it. Okay, let's do another one. Let's say we had solve a minus 28 equals negative 37. So a is our variable, and we know that we need to isolate a. Remember that we are not trying to guess here. We are trying to do it in a systematic manner. So even though maybe you're able to guess the answers, these are simple problems, so you're good. But with more advanced problems as we move through the course, you will find that knowing this technique is the way to go. So I have a minus 28 equals negative 37. And I need to get rid of negative 28 so that I could get a by itself. The opposite of negative 28 is positive 28. So that negative 28 plus 28 will cancel each other. And because I added 28, I will also add the same number on the other side. This leads to canceling off the 28s on the left, leaving us with an a by itself. Now we have a negative number and a positive number to combine. The rule is to subtract the two numbers and take the sign of the larger number. You subtract the 2, you get 9. And the sign of the larger number is negative. Now we need to check our answer. Check. And we take the original equation. We plug in a. The value we got was negative 9. Look at the way you write your a and your 9. Give a little tail so that it doesn't look like a 9. Make your 9, the stem of your 9 longer. So there again, you don't mix them up. So combining these two negative numbers, we add them. That gives us 37, and we take the sign of the larger number. Negative 37 equals negative 37. That's a true statement. This implies a equals negative 9. Box the answer. So we looked at two objectives here. Let me take you way back here. So that's the second objective. Now let's look at the third objective. equations that require simplification. This means you might have to use multiple properties in order to answer the question. Now remember that we are not just looking at only whole numbers. You could expect decimals and fractions too. So I'm just trying to break open the concept, and so I'm using simpler numbers. Solve 9x minus 5 minus 8x minus 6 equals 7. So it's got a string of terms, and we also see that we don't have a single x. We have x that occurs in two places here. Okay. This means we have to fall back on some simplification process before we could actually begin to solve. One of the things we do to simplify is that we combine like terms on both sides first. Okay. So again, like terms are terms that look alike, not terms that you like. So if they look alike, they must have the same variable with the same power. So I look at 9x and the 8x, and I want to bring them close to each other. I take the -5, the -6, and I bring them close to each other. Now this is permitted because we have commutative property that allows us to do it. Without a proper property, without a good premise, we cannot just like that move things around. We're able to move them around because of commutative property. I moved them around so that you could actually see how easy it is to keep the like terms close to each other so that we could combine them. So 9x minus 8x gives us 1x, which is basically your x. And -5, -6, both are numbers, plain numbers. You could combine them. We add the two numbers and take the common sign, which is -11 equals 7. Now that we've combined the like terms, we kind of collected all the variables together, so we now have a single x. And at this point, you could continue to apply your subtraction or addition properties of equality. And so this time we will try to isolate x. And for us to do that, I have to get rid of the -11. In order to do that, I have to add 11 on both sides, +11. That goes away, leaving us with x equals 7 plus 11 is 18. We got the answer. Okay. Again, we could be jubilant we got the answer, but we always need to check our answers. I think that's a smart thing to do. It takes you an extra minute, but it's worth it because it tells you if all you did was right or wrong. Okay. So 9x minus 5 minus 8x minus 6 equals 7. Again, don't be tempted to plug this in a simplified expression. Go back to the original equation and plug it in there. And please don't feel lazy about this because it's really worth it. Okay. So I draw shells in places where I have to substitute. And our answer was 18, so let's plug in 18. I put a question mark there because all these things on the left side should boil down to a 7. Only then will it make the statement true. So 9 times 18, use your calculator and get the answers. So that kind of gives us 162 minus 5. Those two when multiplied gives you 144 minus 6. Again, remember PEMDAS, you have to do the multiplication first. So please watch out for that because if we don't use PEMDAS, we could each be following a different order of operations. That'll be messy because we won't get the correct answer in the same, all of us uniformly. Okay, 157. This is an example, the first example really. So I'm kind of taking it step by step. But eventually we'll be skipping all these things and I will leave it to you to verify. So that is 7 equals 7, which is a true statement. So come back here and conclude your answer and say x equals 18 is the answer. Again, let's not get too wordy because math itself is a language that speaks through numbers and symbols. So it's enough that we write out the answer and box it. Okay. So the previous step that we have, which is identical to the answer we have, that was part of the calculation. So I don't want to mess that. So I'd like to rewrite the answer and box it. It's always good to be systematic. That way we know that we are watching out for all possible steps. So we have another problem. Let's make it a little different. When I say different, in this case, I mean a little lengthy. So let me copy the problem. 3 times 2y minus 1 minus 5y equals 2 times y plus 1 minus 2 times y plus 3. Okay, that looks pretty long. That's the question, so I don't want to tamper the question, so I'm going to rewrite this. And if you consider this equation, it looks complex because of those parentheses, right? So our first step of action is to get rid of the parentheses. We do have a way to get rid of them. We will use the distributive property to distribute what number is outside the parentheses to each term inside the parentheses, and this is the only way to break or drop the parentheses. Okay? We have 3 places where this will work, and so we will multiply them out there. So we have 6y, 3 times 2 is 6. The y cannot be multiplied to the 3, so it just remains attached to the multiplied answer. Minus 3 minus 5y. 2 times y is 2y, plus 2 times 1 is 2, minus, you need to be careful here because you have the minus in front of the 2. It is with a sign that you multiply. So it's negative 2 times y, which is negative 2y. Negative 2 times positive 3 is negative 6. The best way to handle this is combine the signs first. The negative times the positive is a negative, then multiply the numbers. 2 times 3 is 6. So you're taking them in 2 steps, but you're being careful that they're being considered one by one. So we're not losing sight of them. Okay. So at this point, we have removed the parentheses. Okay. So I just want to say what we did. We used distributive property. And now we need to look at these terms, and then we have to understand, well, I have to combine like terms. Okay. So we have 6y minus 5y, which is 1y, minus 3, equals 2y minus 2y. See what happens there, right? So that becomes a 0. Let's say 0y. Just for you to see that, I didn't forget about it. I know that it's going to give me an answer, but I get the answer to be a 0. So plus 2 minus 6 minus 4. Well, this simplifies further as y minus 3 equals 0y is 0 basically, minus 4. Okay. Then we have to isolate y. So remember to apply your subtraction or addition property. In this case, we will add 3, right? So that it cancels off the 3's there, leaving us with just the y. Y equals negative 4 plus 3 is negative 1. Okay. And again, because we want to keep the video kind of short, I will not be doing the check here, but I showed you in the previous examples that you always check by plugging in your answer in the original equation. So I'm just going to write a little note here. I will say, please perform the check by substituting the solution in the original equation. Okay. When I say check, I mean that you're checking to see if you get a true statement, if both sides of the equation come out to be the same. Okay. And now let's look at our last objective, which is to translate and solve application. Well, application is the reason why we're doing all this math, because if it's not going to be applicable in life, right, why would we want to do this? So again, in real life, we don't get equations, right? We get problems that are basically verbal. They're worded, and we kind of make sense of it by converting it into math. So when you hear the word equals, right, you think of the equal sign. When you say is the same as, you think of the equal sign. When you say the result is, then you can think of the equal sign, right? So you have plenty of words that help you translate from English into algebraic equation. So what this means is English to algebra. That's the whole key here. Okay. So if the question says translate and solve, let's say 11 more than x is equal to 54. Again, this is just a warm-up question, right? In real life, nobody speaks like this, right? So it's usually like, this person is 11 years more than the other person, and that is equal to 54 years old, or something like that, So you don't really have very straightforward, explicit ones like this. This is just to help you understand that you can simply translate them word to word. And again, there are more tips in the OpenStax book. This is the free book. So if you go to OpenStax, Elementary Algebra book, you can, let me just write that out here. OpenStax, S-T-A-X, OpenStax. So you have the algebra book there that helps you with more tips, more solved examples, and so on. So this is just an introduction to those sections so that you could actually get an idea of how this works. But again, this video alone is not sufficient. This is only a starter. We'll have to go into the actual book to work through more examples and get a better understanding and look at more different scenarios than explained here. Okay, we're going to do word-by-word translation. 11 is 11. Again, if you were tracking the translation in the book, more than means plus. Okay. Well, x is x. This language is equal to, that means equal sign. 54 is 54 itself. Look at that. Just like that, we translated what was in words into math. Can we solve this problem? Yes, of course we could solve this problem. You want to get x by itself, so let's get rid of the 11. So I will subtract 11 on both sides. That gives us x by itself. And subtract these to 54 minus 11 is 43. Well, it's positive 43. Do not forget to do the check. 43. So 11 more than 43, is that equal to 54? Yes, 11 more than 43. 11 plus 43 is equal. So let's do the check. 11 plus 43 is equal to 54, which gives us the answer. Okay. So come back and say this implies x equals 43. Now this was a word problem, but still it was abstract, so you really could not interpret what this 43 stands for. So we just say x equals 43. But if you do have word problems, then you really want to go further and combine them. and interpret the answer. Okay. Let's do one more. Translate. And solve. The difference of 7a and 6a is -8. Again, let's do word by word. The difference means minus, right? But remember, minus goes in between two numbers. You don't just have a minus, hanging outside, unless it's a negative number, of course. But here they say the difference of 7a and 6a, which means the minus has to go between the 7a and the 6a. The word is itself means equals. And we have a -8. See, there's an example where -8 itself is the other side of the equation. So now you have 7a minus 6a equals -8. Go ahead and solve this, combine the like terms. So 7a minus 6a is 1a, which is simply a. Just like that, we got our answer. So a equals -8. So if a is -8, plug that in and test or check your solution. Then you know that a equals -8 is your answer. Thank you, class, for watching. I hope you will do more exercises in using OpenStax and in your courseware Newton. Thank you.